Hiya. Right, what we're going to do today is we're going to look at how we're using some of the information that we've done before from the periodic table and applying it to something else. So that something else is called relative formula mass. Now you might also see this written as relative molecular mass, and even more often we'll see this written as either RFM or RMM, and you might even see it written as an MR. Okay, so what you should remember from one of our previous units is that on the periodic table we've got lots of chemical symbols, we've got element cells where we have a large number, a small number. We are only interested in this large number. Okay, this, as I'm sure you will remember, is the atomic mass. Okay, so for oxygen the atomic mass is 16, for tin the atomic mass is 119. Now what we can do with those is we can work out this relative formula mass or relative molecular mass by adding up all of the different atomic masses that make up a compound. So we're going to go through a few examples here, and then I'm going to ask you questions afterwards, just so that you completely understand it. So one of the things I want you to do first of all is start looking at the compound and start recognizing what are the atoms that are in this compound. So here we've got sodium, oxygen, hydrogen. I know that this little a is not its own separate element because it is lowercase. It's got a capital N, lowercase a, and then it's got a capital O. And I then know it's a separate element because there's no little letter after the O, it's a capital H. So when I write down what elements I've got, I have Na, I have O, and I have H. Now, if you look at your periodic table, which I'm sure you've got in front of you, of course, you will know that the atomic mass of sodium is 23, the atomic mass of oxygen is 16, and the atomic mass of hydrogen is 1. The next thing to do is to look at the formula. How many sodium atoms do you have in it? Well, here you got wrong, so we're going to go times 1. How many oxygen atoms do I have in my formula? I've got 1, so it's times 1, and hydrogen is also times 1. So if we do that, then we get 23, 16, and 1. Okay, and if we add all of those up, we get 40. Okay, so what I could say there is that the atomic, the relative formula mass or the relative molecular mass of sodium hydroxide is 40. So let's look at water. So H2O, we have hydrogen and oxygen. What we've got here though is this 2. So that's really important. But first, the atomic mass of hydrogen is 1. The atomic mass of oxygen is 16. Now the importance of this 2 actually is I don't just have one hydrogen atom, I've got 2. So here, instead of times 1 like on the previous page, it's times 2. But that 2 is only associated with hydrogen, so I only have the 1 oxygen. Add them up, you get 18. So the relative formula mass is 18 for water. What about O2? Well, there is only one element there. The atomic mass is 16. There are 2 of them, so it must be 32. Getting more complicated now though. but it's not that complicated. This is glucose. Okay, we've got carbon, hydrogen, oxygen. They're the only letters there. That's the only elements that are there. So we've got carbon, we've got hydrogen, we've got oxygen. From your periodic table, you can look up that the atomic mass of carbon is 12. Hydrogen is 1, oxygen is 16. This 6 is only associated with the carbon, it's times by 6. The 12 is only associated with the hydrogens, and this 6 is only associated with that. So we can do the maths here, and we should be able to work that out as 72, 12, and 96. And when we add that up, it's 180. Okay. Calcium hydroxide then. We have calcium, we have oxygen, and we have hydrogen. Now, we've got the calcium there, so we know that I've only got one of them. The atomic mass of calcium is 40, 16, and 1. Complication here. We've got brackets. There's a little 2 over there. Okay, all this means it's 2 of everything inside of the brackets. Okay, so in this case I've got 2 oxygens, I've got 2 hydrogens. I've only got 1 calcium though. So it's 40 times 1, 16 times 2, hydrogen times 2. It's 40, 32, 2 comes out as 74. So the relative molecular mass of calcium hydroxide is 74. Ooh, this is getting interesting now. So, again, you just write down all of the elements that you see. So I've got copper, phosphorus, oxygen. The atomic mass of copper is 64. Phosphorus is 31. Oxygen is 16. I have 3 coppers. Again, I've got my brackets here, and I've got a 2 outside. So it's 2 of everything inside. So I've got 2 lots of phosphorus. But inside the brackets, I've already got 4 oxygens, but I've got 2 lots of everything inside. So it's 2 lots of 4, which is 8. Okay. So again, we just multiply these up. Once we add that together, 382. Okay, so the relative molecular mass of this molecule is 382. And one more. We have Al, aluminium, carbon, oxygen. The atomic mass of aluminium is 27, carbon is 12, oxygen is 16. There are 2 aluminiums, 3 carbons, 9 oxygens. That comes out as 234. We're going to practice more of these. If you're not sure about anything, have a look through the video again, or come and find me. Okay. Thank you very much for watching, and goodbye.